Hi, my name is John Kim. We'll be working on areas and volumes of solids. This is usually reserved for honors geometry, so I'm going to be going a little bit fast. This is actually the book I'm going to be referencing it from. It doesn't necessarily have to be this book. It can be some other book, but usually the questions are going to be very similar. So let's get started with honors geometry, areas and volumes of solids, usually reserved for honors 9th grade students. Okay. So, I'm located in the city of Ventura. I have a business, it's called the Study Room, and we'll start the problem right away on Chapter 10, Study of Materials. So, let me get to Chapter 10 first. This is going to be starting on page 384. And I'm going to put a line right down the middle, save a tree. Question number 1 says, how many lateral faces does a pentagonal prism have? So you're looking for the number of lateral faces. Lateral faces. Question mark. That's what we're looking for. It's a pentagonal prism. So I'm going to change the problem a little bit. I'm going to say heptagonal, H-E-P-T-A-G-O-N-A-L, heptagonal. Heptagon is 7-sided, so it has 7 lateral faces. Of course, I want also the total face. Since it's a prism, it has a face in the 2 bases, the top and the bottom. So we add 2 more to that, and it becomes 9 faces total. Let's do number 2. I like this problem. What is the lateral area of a right pentagonal prism with height 10, base edge of 3, 6, 5, 4, and 8. I'm going to use a different set of information so that you guys can do your own homework. And I'm not here to do your homework. It's your problem, not mine. Every pun intended. So let's get started. Let's say, okay, so instead of a pentagonal prism, as my students would say, let's use octagonal prism. With height is equal to 10 as well, and base edges equal to 1, 2, 3, 4, 5, 6, 7, and 8. These are the base edges, 1, 2, 3, 4, 5, 6, 7, 8, and that's the length of each one of these. Well, what are we looking for again? Oh, the lateral area. So how do you find the lateral area of a prism? So the key word is prism right here. We know that the formula for lateral of a prism is the perimeter of the base times your height, h. Write this down. That's your formula, a general formula. So let's get started. The lateral area is equal to the perimeter of the base is equal to, I'm going to add these a little bit differently. 2 plus 8 is 10. 3 plus 7 is 10. 4 plus 6 is 10. That's 10, 20, 35, 36. So it's the perimeter of the base, which is 36, times the height, which is 10. So it's going to be 360. They give you units. They do not give the units. It's going to be units squared, whatever units that they're using. Okay. Next problem. I actually did some of these out, as you can see right here, so I'm going to reference them once in a while. I did number 3, so let's try that one. Here's number 3. What is the total area of a cube? So the key word is cube. I want the total area whose edge is 3 centimeters. Instead of using 3 centimeters, I'm going to use 4 centimeters. So the edge is equal to 4 centimeters. And that's what I'm looking for, the total area. I have the total area formula, the general formula is the lateral area plus 2 times the area of the base. Some teachers will call that base area, same thing as area of the base. I like to denote it with the area A so that it stands for area. Couple of notes. Let's draw it out, see what it looks like. Notice how I drew the front base, and I drew it backwards like this. Bring it on down. That's what my cube looks like. I can call this the top, and I can call this the bottom. Remember that the cube has all sides that are the same, so it's 4, 4, and 4. Notice that the lateral area is the front base, the right base, the back base, and the left base. So that's the lateral area, and then you have the 2 bases located right over here. So total area is equal to the perimeter of the base times your height plus 2 times the area of the base. 4 times 4 is 16. Perimeter of the base is 4 plus 4 plus 4 plus 4, which is 16, which happens to be the same area, times the height, which is 4, plus 32. So 16 plus 4, 16 times 4 is 64, plus 32 is going to be 96. Square units, they use centimeters. This book is really bad. They but they use centimeters quite a bit. I don't know why. Centimeters is about yay big. I don't know why they use centimeters as a rule. But anyways, so there you have it. What problem did I do? Oh yes, I did problem number 4 next. So let's work it out. What is the height of a right prism with a base area 6 square centimeters and a volume of 24 cubic centimeters? Again, what is the height? We're looking for the height of a right prism. So the word is, keyword is prism, with base area. So the area of the base is equal to 6 centimeters squared. And the volume is equal to 24 cubic centimeters. Well, let's plug in the formula again. It's a prism. You have the volume and the area. Let's use the volume formula. The volume is equal to the area of the base, 2 times the area of the base, plus the perimeter of the base times your height. It was just like, no, we haven't gone to it. This is the formula for the volume of a prism. Perimeter of the base times your height, that's going to be total air, that's going to be your lateral volume. I'm sorry, that's not right. Excuse me. What's going on here? The volume of a prism is equal to area of the base times your height h. That's like totally wrong. Excuse me about that. The volume of a prism is the area of the base times your height. So if you have your area right over here and you multiply by your height, it gives you volume right there. So make sure you know your formulas before you start. These are all from, I'm not even referencing my paper right now, so let's get started. The volume of a prism is already given, 24 cubic centimeters. I don't need the cubic centimeters. Area of the base is going to be 6, and then times the height h. Well, obviously the h is going to be divided by 6. 24 divided by 6 is 4 centimeters. I did use the same numbers that they did. I should have used a little bit different numbers. Anyways, it doesn't really matter. The next problem that I did was number 5.